Last time, people.
Oh.
You don't remember the reviews? What do you remember from last time?
I don't. I
Don't remember
the
anything
ones
from
and
last time?
zeros.
Yeah, that's all you needed to know, man. Ones and zeros. So yeah, this lesson, Unit 2, we're going to start Unit 2, Lesson 1, and it's a lesson on data compression, right?
Mm-hmm.
So the objectives of this lesson is I can know the difference between lossy and lossless compression. I can know where we use compression, and I can answer the question, what is compression? That's y'all objectives, right?
Yep.
That's what you should be able to do at the end of the lesson. Alright, so who knows what compression is? Anybody? What is compression?
So weight on top of weight pushing together.
Yeah, that's a good term of compression. You know what's compression? You know what compression is? What's compression, Dad?
Compression like the bridge.
Yeah,
To bridge something
yep,
from big size to small size.
Yep, that's exactly what compression is. So, what is compression? Well, compression is a set of algorithms that reduce the size needed to represent data. So it can be used on images, music files, videos, and so much more stuff. But you know, since all data is zeros and ones, we need to get rid of some of them because we don't need all of them sitting on memory. So yeah, just remember all data is zeros and ones, and then we use compression to save space, right? And then there's two major kinds of compression: lossy and lossless. What does lossy sound like?
Lossy?
Yeah, there's lossy compression and lossless compression. What does lossy sound like?
Lossless.
Sassy.
No, what is...
Lossy? What do you mean? Be specific.
No, what's in the word lossy?
Lossy?
Look at the two words. What's
Two
the
words opposite.
Yep, they're opposite.
Loss.
Uh-huh.
And lossin.
Yeah. So, there's some comparisons. So, lossy, we'll look at these in the next slide. So what's lossy compression? What do you think lossy compression is?
A loss of compression?
No, it's a loss. Good job. But what are we losing?
Compression?
And?
Extract?
No, we're losing compression and what else?
Size?
What does it mean?
Ones and zeros.
Yeah, we're losing ones and zeros. So lossy, we lose ones and zeros. So in lossy compression algorithms reduce the size of the files by discarding the less important information in the file, which is really good for compression. So we significantly reduce the size of the file, but we also affect the file's quality, right? So this type of compression helps us save a lot of space, but the quality's kind of trash because we're losing ones and zeros. And whenever a file goes through lossy compression, you can't undo it. Y'all understand? So what's lossy compression?
It's like a loss of compression and ones and zeros, and you can't redo it after.
Yeah, so we lose ones and zeros, but then the compression is better than the other one. And then we come into the next one. What's lossless compression? What does that sound like?
Lossless, so you can't lose.
Yeah, you don't lose ones and zeros. So lossless compression, we don't lose ones and zeros. That's the major difference. So lossless compression is a set of algorithms that reduces the file without losing any of the information in the file, which means you can recreate the original data of the compressed file. This type of compression helps us save space, a little bit space, not as much as lossy compression. And the quality doesn't get affected. So everyone kind of uses this compression more often. And it can be undone, so you can compress and uncompress stuff as you want to. But yeah, this one uses techniques that are smart workarounds to not get rid of zeros and ones. Well, we kind of we just remember which zeros and ones we got rid of, so we can rebuild them back.
So does it do anything on your computer?
It saves the file space, so the file sizes. Because you know the computer has a limited amount of zeros and ones you can store.
Mm-hmm.
So we're trying to cram more zeros and ones in there.
Let's say you're like in a Zoom class or something. How much like FPS would you have in it?
You'd have more FPS because you're using up less space. But then yeah. Here's a video on compression. We're gonna watch like
anyone who's ever had to pack for a trip has probably known the frustration of trying to cram almost a suitcase worth of stuff into a backpack. I mean, sure, we could suck it up and leave a few items behind, or haul around our bulky luggage with us if they're so important. But if we did that, then our bag won't fit in the overhead compartment anyway, and all we're trying to bring is a few extra pairs of underwear just in case we eat some bad tandoori chicken. Well, that got gross, but other than that, it was pretty much a perfect analogy for why data compression became so important to reduce storage requirements and to improve transfer speeds over standard connections. These packaging services are kind of like our roommate who catches us standing on our bag trying to zip it up and says, no, you can't just roll your laundry and save like a ton of space, right? And as it turns out, when we try it for ourselves, the smug little turd is right. Not only does all of our stuff now fit, but we even have more room to cram with stuff we'll never use, like that copy of E.T. the Extraterrestrial that we definitely don't watch every night and cry. Back on topic. Obviously, data can't be rolled in quite the same manner as slightly pre-worn laundry, so coding engineers devise algorithms capable of breaking down longer strings of data into shorter ones, then reassembling them later using what they've retained. An easy way to describe this would be like
what type of compression is this? What type of compression is this? Being able to reassemble it later.
Lossy?
Lossless.
Lossless. Good job.
Lossless?
Yeah. What type of compression is it, Mina?
Lossless because you can
Zero.
Yeah.
Times 2 times 2 times 2 into 2 to the 5th power, which is much faster to write and simpler to articulate. But
That's an example of
know a
lossless.
thing or two about coding, and one of those things is that the use of exponential symbols is simply not possible. Well, first off, thankfully we weren't roommates in college, and you talk about smug. Second, you're correct as well. While it is possible to write a command string which describes an exponential function, it usually isn't much of a space saver. So maybe a better way to demonstrate how a compression algorithm works is to use something like a string of X's and O's, or zeros and ones if you're catching the similarities here. Let's say we have a string of 8 digits, which is spelled out as XXXOOXXX. Now, an algorithm may look at this and decide that every time it comes across a new digit, it will replicate it and then note how many times it's been repeated. This would cause our string to transform into these smaller.
These are examples of like lossless compression, which we'll look at the more lossless compression.
It only managed to do so by 25%, which isn't exactly going to allow us to cram our drives full or transfer large files over the internet more efficiently. That's where more specifically designed algorithms will come in to strip the code to its most basic form, instead simply adding all the X's together by treating each of
What is this form of compression?
Lossy.
Yeah.
as a value of 1, then listing all the O's followed with a digit count as before. Then we end up with a string that would look like 3023, which we can now see is half the size of the original code. Now obviously this example is rudimentary at best, but it gives an idea of how mathematicians are able to achieve and then further improve upon this feat as time goes on. Now, this example would be known as lossless compression. All of the original data remains intact and is a requirement for programs or documents. But if you're willing to give up some detail in the original file, lossy compression algorithms can be used for media files like music and movies. As long as you understand that the tighter you cram it, the lower the playback quality you'll experience. It's actually learn a little bit more about here in our video specifically about video compression. Speaking of compression, no, not compression. Okay, whatever. We've got a new sponsor today on Tech Week.
That's it.
We got a sponsor.
Yeah, we don't care. Anyway, so y'all understood. What are 2 things y'all understood from the video? George.
So basically, lossless helps cram it together, and it basically like makes XXXOOXXX, and X3, the lossless.
No, lossless can. Mina, which ones cannot be undone?
Lossy.
Yep. And so, what is compression again?
Compressing something
Yeah, to do what?
to work or to
save
make
room.
it smaller.
Yeah, to save space.
To save room.
Yeah, memory space.
Room.
Y'all know the difference between lossy and lossless compression? What's the difference?
Lossy, you can't. It doesn't save you, or it saves you more space, but you can't get it back.
Yep.
And lossless, you can save space while keeping it and getting it back.
Yep. Y'all ready to play some Kahoot? Y'all don't want to play Kahoot? No, keep it on the video. Belly, I do. Keep it on, dog. Why are you... Just keep it on. Y'all ready to play Kahoot, y'all? Grab a camera. Or grab a device, man.
تلعب على البتاع ده؟
Yeah. I got you. Just go grab something. Keep it on, dog.